Hi, my name's Evan Souza and I'm in EEC 10 and this is my final project. Right here is the two microphones that we built with circuitry, and that's hooked up to the MIDAC that we're supplied, and we also have a microcontroller that's hooked up to my computer and a servo motor. So this is the final project, the front panel of it. What we have here is different aspects. Like this displays the graph for the two microphones. So the right microphone is the red and the left one is the white. You'll see that in a bit. This is the file that gets recorded. So when sound comes into the microphone, it gets recorded, and then my program saves it to a file on my computer, and this is a directory to that file. This is the port in which we talk to the servo motor with through the microcontroller. And then I implemented a feature where you can have a low cutoff frequency and a high cutoff frequency, and you can set that to whatever value you desire. And then this is the time delay. So once you pressed record, you can say how long you want it to wait until it actually starts recording in milliseconds. So if I put 1,000 milliseconds, it will wait 1 second before it actually starts recording. So let's run this. And then as you see, as we're talking, these are what each microphone's receiving. This is the audio signal we're receiving. And then through the servo motor, you can see when I snap over here, the servo motor rotates to the right to show where I'm snapping, and then I snap back over here. Over here, it rotates back, snap over here, rotates that way, and then rotates back. So now we want to look at the file that we just recorded. So while we were doing that, we were recording a signal. And so we can go to that in my computer. As we're talking, and then we can hear it. What each microphone's receiving. So that's the file we saved it to. And this is my front panel. And now we go to my lab view where everything is generated from that front panel. Here you can see this is all the code I need to save it to a file. This is where the MIDAC processes the data from the two microphones. So it turns analog signals into digital signals through the MIDAC. So it's pretty much just takes in the signal from the microphones and it converts it to digital signals. And then here you can see this is my filter, where I can filter the low frequencies and the high frequency to just have a bandwidth filter. And then next, I split my signal into two signals, therefore I can calibrate it through this multiplier. So since this signal was weaker than the other signal, I had to multiply it by a factor of 2.4 to calibrate them and make them the same. And then here I measured each amplitude for each signal, and then I compared them to make sure that if they're above a threshold, then they can go into a K structure. And this is where the servo motor gets communicated to by LabVIEW using VESA. This is the VESA right and this is the VESA close. So when I snap to the right, it knows to rotate 0 degrees, and when I snap to the left, it knows to rotate 180 degrees. And this is what gets written to the servo motor. Now we come back up here, and then we can see that I joined the two signals again, and then this is the graph on my front panel. This is the time data, and this is the final place where I write it to a file. So that's basically my final project. Thank you.